Alright, today we are doing section 7.4, showing triangles similar with side, 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 and side angle side. These are different from the side, 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 and side angle side that we learned before. They're not a lot different, but they are a little bit different. Anybody need more time with their objective? Alright, so let's talk about the warm-ups. Write a similarity statement. That one shouldn't be so bad because we just did that several times. Since these are not triangles, we don't really put a symbol in front of the letters. So how do you want to name one of them, Jakeem? So that is one of the ones we can't do. You cannot go PQ, then cross over to S, and then to R. So if we go PQ, we would have to go RS. So PQ, RS. It doesn't matter to an extent. And in triangles, we don't usually have to worry about this. But you can't make a diagonal as you're naming it. So it's got to go around the shape. All right, if we name the first one PQRS, what is one option for naming the second one? Careful. TUVW. Again, can't cross over. TUVW. You could technically name it UTWV because we've got multiple pairs we could match up. What's the similarity ratio, also known as the scale factor? So give me two sides that we can compare that we know both of the sides. Okay, SR and WV, we know both of those down there. We know this one and this one. So if we put those in a ratio, 6/8 simplifies to be 3/4. Divide them both by 2. We can use that to help us find x. So to find x, I'll show my work down here. We set up a proportion. One side we can use that scale factor or ratio. What do you think would go in my other ratio? Very good, 12/x. When we cross multiply, 3x equals 48. So x would equal 16. This was a commonly missed type of question on your quiz. A lot of people, if this had been the question, what a lot of people did was just say x equals 12. They assumed that those sides were going to be congruent, and that is not the case. So for example, if this had been the question on the quiz, a lot of people apparently would have told me that y is equal to 12. Which again is not going to come out to be the case. So let's find y. We'll start with that same similarity ratio or scale factor. What should go in my other ratio? y/12. Okay, we match up QR to UV. When we cross multiply here, we get 4y equals 36. So y would equal 9. Questions about the warm-ups? Concerns? Need more time? Okay, moving on. Side similarity theorem. So this one's also called SSS. You may want to add a little similarity symbol next to the SSS. So you might want to call it SSS squiggly. So you remember it's different from congruence. If the corresponding sides of two triangles are proportional, then the triangles are similar. We've kind of already looked at this. We just usually knew the angles at the same time. So this one's saying if we know nothing about the angles at all, but all of our corresponding sides end up with the same ratio, then the triangles are definitely similar. If you really want to, you could give these triangles numbers. You could say, for instance, the FG has sides of 3, 6, and 10. Nope, that wouldn't work. 3, 6, and 8. And then you could say that ABC has sides of 6, 12, and 16. I'm just choosing an easy scale factor to use. But if we were to compare corresponding sides, here they put FGH on top, that triangle on top, ABC on bottom, then all of these ratios would reduce to 1/2. 3 over 6 is 1/2, 6 over 12 is 1/2, HF over CA is 1/2. It doesn't have to be 1/2. We could have forced it to be 1/3, 2/3. This one we'll label as triangle A. This one will be triangle B. Okay. We are asked to determine if these triangles are similar. We know nothing about the angles, so we have to only go by the sides. What do we think? Similar, not sure. Sam T, pick your head up. Crescencio, what do you think?
I think it's similar.
They are similar. I would agree with that. So this one, it's pretty easy if we compare our sides. Give me a side from the first triangle. Okay, so ST has a length of 2. That would compare to PQ, which has a length of 6. That reduces to be 1/3. Give me another pair. Okay, so SU and PR. 3 over 9 simplifies to be 1/3. Remember, the other way of doing this is picking the smallest side. Like smallest side to smallest side, middle side to middle side. The biggest side for one of my triangles is 4. The biggest one of the other one is simplifies to be, okay, so we've done something like this before, but this time we're saying that because we get the same ratio every time, that's enough to tell us that these are similar triangles. We are asked to write a similarity statement. So triangle blank similar to triangle blank. How do you want to name your first triangle?
TSU.
Okay. TSU is similar to triangle QP. I think that's a Q. QPR. Okay, again, I don't care how you name your first one. Your second one better match up. The last part tends to be the trickiest part. Find the scale factor from B to A. Careful. From B to A. 3/1. So it's fine that we found this to be 1/3. That's the same ratio the whole way through. But which triangle did we always use on top? Triangle A. We always put this one on top. If they say from B or of B to A, then you better put a side from this triangle on top, which would flip all of these. So this one we have to realize that our scale factor is flipped to 3/1 if we're going B to A. That was another commonly missed point or two on the quiz. Make sure you're paying attention which one they want you to start with. Questions about example 1? Okay. We've got the same kind of directions. Did anybody make a decision about number 2, whether those are similar? Lexi, what do you think? Lexi says they are similar. Who agrees with Lexi? I believe we should, so let's double check it. Let's start with B just to make it easy. What's the smallest side from triangle B? Smallest side from triangle B is 8. So we would be comparing 8 to the smallest side of the other one. Somebody said it, but 12. Okay, that simplifies to be 3. Right? I think you got it flipped. Okay, this one would be 2/3. I went ahead and started with B. If you started with triangle A, for right now, that's fine. So if you had 3/2 instead, that's okay. For right now, I'm just doing it this way so I don't have to flip it later. Okay, what about the second smallest side from B? 10/15 reduces to be... Okay, we're in good shape. We still have to check the last pair, which would be
12/18.
Reduces to be
2/2.
2/3 as well. So I agree these are similar. How do you want to name your first triangle?
ABC.
Okay. Is similar to
XYZ.
X, Y, Z. And our scale factor is 2/3. If you had gotten 3/2, 3/2, 3/2, that's fine up there, but the direction said scale factor of B to A, which is why aside from B would have to go on top for that. Anybody make a decision about number 3? Kylie? Not similar. I would have to agree. My smallest side from B is 9. That would get compared to 5. Okay, that doesn't reduce, so we move on. My next smallest side from triangle B is 12 compared to 12, and that reduces to 1/1. So 9/5, 1/1, not the same ratio, so these ones are not similar. You could check the third side, or third pair of sides, but it doesn't really matter. They're not similar either way. The last pair of sides just gives us another ratio that's not the same. Questions about side, side, side? Okay. Let's talk about side angle side. Some of you may have been able to guess what this one's going to say. I'll give you a couple minutes to write before we start talking about it. Kind of like with side, 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 you might want to add a little similarity squiggly after that so that you remember this is different from when we did side angle side for congruence. Otherwise, it's a similar idea. So, if an angle of one triangle is congruent to an angle of a second triangle, that part's the easy one. So, in this case, they told us angle X congruent to angle M. And the lengths of the sides that include these angles are proportional. So, the important part here is included. Then the triangles are similar. So they had to use... Hi. We had to use sides PM and MN because those are the ones that make up angle M. We had to use sides ZX and XY because those are the ones that make up angle X. Okay, there's really no way of marking proportionality in a diagram, so there's really nothing for us to put on those sides. I would not put little tick marks because these are not necessarily congruent. Questions or need more time before we practice with these? Okay. Determine whether the triangles are similar. If they are, write a similarity statement. Of course, these numbers in the angle should have little degree symbols on them. Alright, so from side angle side, the easy thing to check is the angle. Do we have a pair of congruent angles? Yep. So if we're checking side angle side similarity, we could put a little check mark over the angles. We do have a pair of congruent angles. So then we want to make sure that the sides that are around the angles are not necessarily congruent, but that they are what? Proportional in the same ratio. Something along those lines. So we would compare 3, so side AC, to what side? 5, DF. And we would compare 6 to 10. 3 to 5 will not simplify, but 6 to 10 simplifies to be 3 over 5. So are these sides proportional? Yes, they are. So we checked that the sides around the angle are proportional. Therefore, these triangles are similar. So we would say triangle ABC is similar to triangle DEF. Again, if you called it something like triangle CAB, the other one would have to be FDE. It's not the only way to write it, but it is one way. Questions, concerns about example 4? Need more time. Moving on. Show that triangle VYZ is similar to triangle VWX. So VYZ is the big triangle. If it helps, you could draw them out. Sorry, bring it back. Draw them out separate from each other. So we've got this triangle, VYZ. And then we've got a smaller triangle, VWX. 4, 5. What should I label side VY if I separate these?
Y, I mean X. Wait. 4.
Oh,
Did you
12, Y12.
did you add this after?
Good. We add those little pieces together. We would get a 12 here. What about for side VZ? 15. Are we all okay with why we have to make those numbers bigger when we add them? We could also mark a pair of congruent angles. Which angles would have to be the same in these two triangles when I draw them out separately? I thought I heard somebody say it. V would have to be the same by the reflexive property. We drew that same exact angle from the top both times. So if we draw them out separately, it makes it a little easier to check side angle, side similarity. We already have a pair of congruent angles. So we need to make sure that the sides around them are proportional. So I would compare the 12 to what side from my other triangle? 4. That simplifies to be 3 over 1. I would compare the 15 to 5. That simplifies to be 3 over 1. Are my sides proportional? They are. So we showed that that's true. We marked our congruent angles. We showed our ratios. If you put the small one on top and your ratios were 1 over 3 instead, that's fine. They already gave us a similarity statement. We don't have to write it again. But we marked our congruent angles and showed our proportional sides. Questions about example 5? All right, I want you to do this one real quick. This one's going to be similar to the last one, where it might be helpful to draw these out separately. Or you could just make this diagram, but then mark that this side is going to have a length of 56. And this side down at the bottom would have a length of 49. We all okay with how I got the 56 and 49? By adding those side lengths together. What angle would be the same if we were to split these up? Good, angle L, so we could give it a little mark. Or we could come over here and say angle L is congruent to angle L. Something so that I know that you know that that angle is used twice. If we are checking our sides from our little triangle, we could use the 16. And it would have to get compared to, good, this big side here from my other triangle is 56. What would that reduce to? Well, it can reduce some way. They're both divisible by at least 2. What would that reduce to?
8 over 28.
Okay, 8 over 28. Those are both divisible by 2. 4 over 14. Those are both divisible by 2.
2 over 7.
2/7. That's as small as it's going to get. So it will reduce. If you reduced it right away by dividing top and bottom by 8, that's fine. But if you're not sure if they're both even, you can start with 2. What's the other ratio I need to look at? 14/49. Those are both divisible by 7. We get 2/7. If they're telling you to show that two triangles are similar, then you better be able to get those ratios to match. If they're saying show it, they're saying this is definitely true, you need to give me the pieces that prove it. So then we would say that we used side angle side similarity to do that. All right, we might be able to wrap up that last example. I don't think you need that last one for your homework today. So we will leave our notes here for now.